Yeah, next topic is get and set properties. So get and set properties in C sharp acts as a acts as a protective layers around your class variables, allowing you to control how other parts of your code can access and modify them. So this mechanism is crucial for encapsulating data, ensuring that internal state of an object is safe from excuse me internal state of an object is safe from unintended changes and misuse. So the basic use let me just copy the code. So we have a direct access. So public string first name get set. This line allows direct access to first name, uh, enabling reading and writing operations. So and we can also do this. It's an initialization at declaration, public string last name get set is equal to Smith, which sets as a default value of the last name while maintaining the read and write capabilities. So this is the basic example of get and set. Uh, by including code blocks in get and set properties, you can execute additional logic when a variable is accessed or updated. Um, yeah. So this is the syntax for get and uh, for get and set example. So the get block must return a value. Uh, it's where you add logic to manipulate or validate the data being accessed, and the set block assigns a value, often with some form of validation or transformation. The value keyword represents the new value being assigned, and uh, we'll have the like the public and the private, which is backing variables. So a private variable that holds the actual data, it's only accessible within the class itself. And we'll have the public accessor, which is the public variable with get and set properties, provides controlled access to the backing variable, which is the private variable. uh, So this setup ensures data encapsulation by exposing a public interface for accessing the private data, therefore safeguarding the data integrity. Here we have a first name which returns the value of the private variable. Here the set each updates the private variable with a new value. uh, so when applying this to game development, such as in game manager class, these properties enable you to safely track and modify game states such as player health or score without directly exposing the underlying variables to external modifications. So this ensures that any changes to crucial game data go through a controlled pathway, potentially including validation or triggering other game events. For example, updating the player's health could trigger a check to see if the player's health drops to zero, and subsequently execute a game over routine. By using set and get properties, you maintain a tight control over how these critical game states are managed and manipulated throughout your game's code base, and enhancing the robustness and reliability on the game's internal logic. So that's about next is, so in this segment we are exploring how to use backing variables in C sharp for more secure and efficient data management within the Unity game development environment. So let's discuss the process and understand how it applies to our game behavior script, uh, specifically focusing on tracking player properties like items collected, player data, player health points. So, so what are backing variables? Backing variables are private variables that store data behind a public property. So this structure allows you to control access to the value the variable holds. So in the context of Unity game, these can be crucial for keeping track of player stats without exposing them directly to the other scripts or components that could uh, inadvertently modify them. So in the behavior script, we are tracking uh, two pieces of players data. Let me, yeah, yeah. So yeah, we are tracking two pieces of player data, which is the items collected and where is players HP? Yeah. So players health points, players HP. So these are private integers that cannot be directly accessed or modified outside this class. So uh, we have a public properties with get and set. So for each private variable, a public property is declared, for items and health points. So these properties utilize get and set accessors. So in the get accessor, we this allows other parts of the game to read the value of the private variable. So when items or HP is accessed, the get accessor returns the current value of uh, the items collected and uh, player HP. And whereas in set accessor, this controls how the value of the private variable is updated. So when a new value is assigned to items or HP, the set accessor updates items collected or player HP with this new value. And also if it logs the updated value to the console using a debug.log format, providing a real-time feedback mechanism for you. So why use this pattern? Utilizing backing variables with set and get accessors offers multiple benefits. Like first one is like the encapsulation, data encapsulation. So it keeps data safe from unintended modifications, encapsulating the logic of changing these values within the game behavior class. And validation, and the side effects. So if needed, you can add validation logic within the set accessor to ensure that the data remains consistent. Similarly, logging or triggering other actions when data changes, as done with the debug.log format, are easily managed here. And the other benefit is flexibility and control. You can maintain complete control over how and when your game's data is accessed and modified, all from a central location. This setup is invaluable for complex game mechanisms where data integrity is crucial. So an application like an example is, imagine the player collects an item in the game. Instead of directly modifying the items collected variable, you would increment the items property. So this increment would automatically invoke the set accessor, updating the items collected and logging the new total to the console. Through this approach, the game behavior script effectively becomes a secure and manageable hub for player related data, allowing for controlled interactions and modifications based on the key mechanics such as collecting items or taking damage. This method not only makes your code more robust and easier to debug, but also lays down a solid foundation for expanding game functionalities in a controlled manner. So that's about backing variables and properties. Next is Item collection. So to effectively incorporate item collection updates within your game using Unity C Sharp scripting, uh, you need to modify the item behavior script. So this item behavior script is responsible for interaction between the player and collectible items in the game. So let me pull up the code. Yeah, so you begin by creating a public variable, which is the game behavior within the item behavior script. This variable named game manager uh, will hold a reference to the game manager script, enabling access to its public properties and methods. And in the start method, you initialize a game manager variable by searching for a game object named game manager. In the scene, and use the object dot find game manager to locate it, and dot get component game behavior to access the game behavior script attached to it. Um, and in the on collision enter method, which is triggered when a collision occurs, check if the collision is with the player. If so, player performs sorry perform you'll perform the following actions, like the destroy the item to simulate its collection using this line of code. And you log a message indicating item collected using debug.log. And you increment the items property of the game manager to update the item collected. Since items has both getter and setter, updating this property will also trigger any additional logic defined in the setter, such as logging the updated item count. So by incorporating these steps, you link item collection in the game world to the data tracking and management within the game behavior script. This allows for a clean and organized way to update game states, such as the number of items collected, and provides a foundation for expanding game functionality and interactivity. Uh, yeah, so this implementation um also explains the importance of cleanly separating concerns within your game code. Item behavior manages the interaction and collection of items, while game behavior manages the state and properties related to game's progress and players' achievements. It's about it. Next topic is UI elements. So to enhance a player's experience in the, for example, the hero bond, we aim to provide feedback on game progress and status through UI elements. Unity allows us to craft these interfaces programmatically using the GUI class or directly using the editor. So in this project, you'll will focus on programmatic approach to basically reinforce coding skills and ensure consistency across the game mechanics. So UI, user interface. um, User interface components are essential for interaction and display in games, providing a critical information such as health, item count, or game messages. Unity offers a versatile set of tools for creating UI elements, which can be added directly through the hierarchy panel or coded with the GUI class. For our purpose, the latter will be our method of choice to introduce UI elements that reflect the player stats and game notifications. So the GUI class, graphical user interface, in Unity is a powerful tool for creating and managing UI elements directly within scripts. This approach allows for dynamic updates and interactions based on the game events. So Unity executes all GUI class method calls within a special mono behavior method called onGUI, similar to the update method on GUI method runs multiple times per frame, acting as a dedicated processor for UI rendering and interaction. So some of the key points for adding player polish through UI is UI elements like we aim to display player stats such as item count and health, and also will include a text box for event notifications, enhancing player engagement and understanding of game mechanics. And coding, programming UI with the GUI class. We are will utilize Unity's GUI class. We will programmatically add these UI components within the game behavior class. So this method ensures that our UI is dynamically linked with game data, providing a real-time feedback to the player. On GUI method, so this is a special method uh, within the mono behavior lifecycle is where all our GUI related code will live. It allows for the creation, positioning, and updating the UI elements based on the game's current state. Uh, so so the game behavior script is designed to manage game states such as player health, item collection, providing visual uh, feedback to the player through Unity's GUI system. So let's look closely on how the script works and how each part of the code contributes to the game's functionality. So let me pull up the code. Okay, so uh, yeah, we have this is the mono behavior script. We have label uh, text which holds a string that changes dynamically based on the game state, providing players with instructions or updates on their progress. And we have a yeah, max items, which determines the total number of items the player needs to collect to win the game. And as I mentioned before, items collected is basically tracks the number of items the player has collected. And yeah, player HP, sorry, yeah, as I mentioned, it tracks the player's health points. uh, yeah, property items with getter and setter. This property wraps around the items collected and includes logic to update label text based on how many items are left to collect, or if the player has collected all items. And we have a on GUI method, which is this method is where GUI elements are drawn on the screen. So GUI.box, so this line of code draws a box at the top left corner displaying the player's current health, and this line draws another box below the health box showing how many items the player has collected. And this line draws a label at the bottom of the screen showing dynamic messages stored in the label text. This label is adjusts its position based on the screen size to always appear centered at the bottom. So so the GUI elements update in real time to reflect changes in the player's health and items collected. So the on GUI method ensures that these elements are redrawn every frame. So any changes to player HP or items collected or label text are immediately visible to the player. Uh, so to use properties with custom getter and setter allows the script to encapsulate uh, game logic game logic related to health and item collection. So this approach makes the code cleaner and centralizes the logic of updating game states and UI elements. So this script uh, explains how to use Unity's immediate mode GUI, which is IMGUI system, to create a simple but effective on-screen display for game states. So it demonstrates the power of properties in C Sharp for managing game logic and the flexibility of Unity's GUI system for real-time player feedback. Next is winning condition, a win condition. So when creating a game, defining a clear win and loss conditions is crucial to structure gameplay and provide goals for players. So for example, in the Hero Bond project, we winning is tied to collecting all items within the level while retaining at least one health point. So let's discuss about implementing the win condition and how the game's UI and mechanics adapt to signify the win condition, which is victory. So let me open the code. So we have a yeah, it's we are using the same script, the game behavior script. We have a boolean variable which is show when screen is introduced to manage the display of the when screen, initially set to false. It acts as a switch to trigger UI changes upon meeting when conditions. uh, Sorry. And uh, okay, that's it. Yeah, so the game tracks item collection through a private variable, the private variable items collected and a public property items. The set accessor for items not only updates items collected, but also checks if the player has gathered all required items, signaling the game completion. And upon collecting all items, show when screen is set to true, triggering the game to enter a state where victory can be announced. And the logic embedded within the items ensure real-time tracking of game progress and an immediate response once the win condition is met. Uh, and So utilizing the Unity's on GUI method, a conditional check for show when screen sorry, determines when to display the when message. GUI button is dynamically created to serve uh, as a notification. You won an interactive element, although its click functionality awaits further development. But yeah, so for testing purposes, the max items attribute is uh, temporarily adjusted to allow for an easy demonstration of win mechanic. So this step is crucial for ensuring that the game reacts as expected uh, when win condition is met. So this implementation not only tracks player progress through item collection but also introduce an interactive element to signify game completion. So by carefully structuring and game the game's logic and UI elements, Hero Bond becomes more engaging experience that rewards players for achieving goals. Uh, further expand Further expansion will likely enhance this mechanism, like adding actions for win button and simply integrating loss conditions uh, to improve the gameplay further. So next is uh, pausing and restarting the game. So let's break down the code step by step, making it easier to grasp the concept involved and how they come together to pause and restart the game upon upon winning. Uh, Let me pull up the code. Uh, so here we have a new namespace. So namespaces are essential in C Sharp to organize code libraries and avoid naming conflicts. They are they are especially useful in large projects with multiple classes and derivatives. So using derivatives at the beginning of C Sharp scripts, like for example, using Unity Engine, grants access to different namespaces, allowing the use of classes and methods within those namespaces without needing to specify the full path every time. Uh, yeah. So Unity Engine dot scene management, by adding using Unity Engine dot scene management, we gain access to functionalities for loading scenes which are important for restarting the game. So this namespace isn't included by default and must be explicitly added when needed. What else? Yeah. So this line pauses the game by stopping all time-related activities, including player input, physics calculation. It sets when the win condition is met, and yeah, and here we this method restarts the game by loading the scene at index 0. Scene indexes are defined in the build settings of your Unity project. So this command is executed when the player clicks the U1 uh, button, and time dot scale time, this line is so resetting the time dot time scale is to its default value resumes the game, ensuring that everything moves and behaves normally once the scene is loaded. So what we did here is the script starts by including the required namespaces, is with using Unity Engine dot scene management being important for scene management tasks, and time scale. So upon meeting the win condition, the game is paused by setting time dot time scale to 0, effectively freezing everything, and a button is displayed using the GUI dot button uh, when the win condition is met. Clicking this button triggers the scene to reload using the scene manager dot load scene, and the time is set back to normal speed to resume gameplay. So this setup not only enhances gameplay but introducing win conditions and outcomes, but also demonstrates the practical use of namespaces and scene management in Unity to control the game flow. Uh, yeah, that's the end of these topics. We discussed about game jumping mechanics using rigid body, applied force. We discussed about projectiles using prefabs, uh, collision control, enumerations, get and set properties to safely access and modify game data, namespaces. We discussed about namespaces. Just now we discussed about restarting and pausing functionalities, and UI elements, basic user interface components which shows player stats, game feedback. Uh, Yeah, we'll discuss about AI, enemy AI, in the next topic. So